Hi class, my name is Stan Forrester. I'm your instructor. This is lesson 4.5, inverse matrices. We're going to make a definition here. The matrix H is the inverse of matrix G if their product is the identity matrix. And that should actually be a period. There's no question about that. This is a definition. So in other words, if we take the product of G and H, and is it equal to the identity matrix? Remember, the identity matrix is a square matrix where all of the diagonal elements are equal to 1 and all of the off-diagonal elements are equal to 0. So, is the matrix H the inverse of matrix G? Well, let's find out. So there's G. We have a defined G, matrix G, and a defined matrix H. So GH, we're going to take these two matrices, we're going to place them next to each other. And in matrix multiplication, we're going to take a sum over products. Okay, here we take the first row. That doesn't do the root. The first row of the first matrix, and we're going to multiply that by the elements in the first column. So notice that when we come down here to do the first element of G times H, we're going to be using a 1 and a minus 3. So here's your 1 and your minus 3. And we're going to multiply 1 times 7, because that's the first element in the column. The second element in the row is minus 3. We're going to multiply that by 2, which is the second element in the column. So 7 is just going to be 7. Minus 3 times 2 is 6. 7 minus 6 is 1. Yeah, we look like we're in pretty good shape right now, okay? So let's take a look at one of the off-diagonal elements. We're going to look at this one here in the upper right of the product. And again, because this is in the upper, we're going to use the upper row, but it's in the last column of the product, so we're going to use the coefficients here in the last column. So again, we got 1 and minus 3, 1 times the 1, which is the first element in the first row, times 3, which is the first element in the second column, because remember, we're doing first row, second column, and then minus 3, which is the second element in the first row, times 1, which is the second element in the second column. Okay, so let's take a look at that. So basically we have 3 minus 3, again, 0, and we're looking good. Okay, so now let's see if we can figure out this next one here. We need to figure out the element, which is on the left, but the lower row. Okay, so let's figure that one out. We're going to use the second row of the first matrix, and we're going to multiply each of those elements by the first column in the second matrix. So this is minus 2 times 7, minus 2 times 7, and then we're going to add that to 7 times 2. Well, it just differs by a minus sign. We know that's going to sum to 0, and again, we're good to go. All right, so real quick here, we're going to use these coefficients again, minus 2 and 7. We're going to multiply them by 3 and 1, and so 7 minus 6 is 1. This one comes to 0. That one comes to minus 6 plus 7. That's going to be 1. And indeed, the H is the H is the inverse of G because their product is the identity matrix. Okay, so here's a quick question for you. Is the reverse also true? Is G the inverse of H? I'll let you think about that one for a little bit. And you might even try it out and ask yourself, if it turns out to be true, you might ask yourself, why? Why is it true? Okay, so here's our next example. Is matrix K the inverse of matrix J? And I've taken a slightly larger matrix here in both sides matrices so that we can have a slightly more complicated one. And again, what we're going to do is we're going to take the elements in the first row, and we're going to multiply them by the corresponding elements in the first column to get first row, first column, to get the element that's in the first row, first column. Okay, first row, second column is going to give us the element that's in the first row, second column of our product. First row, third column. We're going to use these same coefficients that we were using for all the other first row of the product. And this time we're going to use the elements. We're going to multiply each element in turn, each element of the first row in turn by each element of the first column, third column. I have a correction on that. So we got -1, -1, 6, -1, -1, 6. And we're going to multiply each of those in turn by 2, 4, and 1. 2, 4, and 1. And it's just going to... Okay, so if we look here, we can see that we have some zeros. Now, I went ahead and I made sure to go ahead and put up the product, say for the middle element, when we're trying to figure out what the middle element of JK is, the second row, second column element. I made sure to leave in the 0 so that I don't get things out of order. All right, so our coefficients here for this element, which is the second row, second column, we're going to use 1 times 0, well, 1 plus another term times 0 plus another term times -2, and we're going to multiply that by 3, 3, and 1. So there's 1 and 3, 0 and 3, so you have 3, 3, 1 times -2. And already there, we're looking at that. That doesn't quite look right. It's 3 minus 2. And my intuition was wrong. And so, yes, indeed, it's 1. Okay. So let's take a look here. This is the second column, third row. And we're going to have second column is 1, 0, -2, but we're going to multiply each of those elements in turn by 2, 4, and 1. 2, 4, and 1. And that's going to be 0. This is an off-diagonal element. That's what we expect. So let's come down here. For the product, we're going to be looking for, this time we're going to be looking for the third element in the first, third row, first column. Third row, first column. So we're going to take third row coefficients, 1, 0, and -3, 1, 0, and -3, and we're going to multiply those by the elements in the second matrix, first column, 2, 3, 1. So 2, 3, 1. So here's a 2, there's a 3, and there's a -3 and a 1. And that's a 2 minus 3, that's a -1. Oh my. That is not equal to 0. And that's really all you need right now to tell yourself that, okay, this is not the identity matrix. We don't really need to go any further. You have that conclusion. It's not the identity matrix. There's another one here that's a little hinky, and I'm going to leave it to you to show that the final element, the third column, third row of the product is actually equal to -1 rather than, we might have expected +1, but we got -1. And so either one of these facts, the fact that this is not equal to 1 and the fact that this is not equal to 0, either one of those would have been sufficient to say that this is not the identity matrix. Okay. If you have any questions, please post them in the discussion board and I'll do my best to answer.